Hello. Today in the course Fundamentals of Building Construction, we are going to discuss about the topic hardened concrete. Before we go into our topic today, I want to give you a brief overview of what we have already been going to cover in this session. Today, we will be exploring the hardened properties of concrete, starting with a comprehensive introduction that sets the stage for understanding about the hardened concrete, and thereafter we move to understand the various other aspects. We will discuss some key points like number 1, the factors affecting hardened properties, second, the strength of concrete, third, testing of hardened concrete, fourth, non-destructive testing on concrete, fifth, the elastic, creep and shrinkage, and lastly the sixth point will be about durability of concrete. The water cement ratio, we have discussed about water cement ratio at length in previous lecture. The water cement ratio leads to higher strength and durability if it is low, but it may make the mix difficult to work. The workability can be resolved with use of plasticizers or super plasticizers if lower water cement ratio is there. However, a mix with a ratio of 0.38, that is the minimum water ratio which is required for the complete hydration and gel formation, it may not mix thoroughly and may not flow well enough to be placed. More water is therefore used than is technically necessary to react with the cement. Water cement ratios of range 0.45 to 0.6 are more commonly used. The nature of strength of concrete. The strength can be defined as the ability to resist the force. Strength is a good index of most of the other properties of practical importance. In general, stronger the concretes are stiffer, more watertight and more resistance to weathering, etc. The rupture of concrete may be caused by applied tensile stresses, the shearing stress, or by compressive stress, or a combination of two or more of the above stresses just discussed. Concrete, being a brittle material, is much weaker in tension and shear than the compression, and the failures of concrete specimen under compressive load are essentially shear failures on oblique planes. It is called as shear or cone failure. The angle of internal friction of concrete being of the order of 20 degree, the angle of inclination of the cone of failure in conventional test specimen is approximately 35 degrees. Maturity of concrete. The concrete maturity is an index value that represents the progression of concrete curing. It is based on an equation that considers the concrete temperature, time and the strength gain. Concrete maturity is an accurate way to determine the real-time strength values of curing concrete. The tensile and compressive strength of concrete. The concrete has enormous compressive strength, that is the ability to withstand heavy weights or forces on it. It also gains strength with age. The concrete will solidify in few hours and harden or set in a few days time, but it continues to gain the strength for at least 28 days. Some very thick concrete structures like dams, they continue to gain strength for months or years. Concrete has almost no tensile strength or the ability to withstand pressing or stressing. Concrete can resist compression but will break under tension. Concrete cracks in roads and slabs are mainly due to tension. Different weights in different areas produce tensile forces. The tension to compression ratio for concrete is about 10 to 15%. That is, it can withstand about 10 times the pushing force or compression of the pulling force or tension. But both strengths increase with age, but the ratio is steady. Now, factors that affect the strength of concrete. We are concerned about how much the strength concrete is gaining. We have discussed in the previous lecture, concrete strength is affected by some of the factors like raw material that is being used for making the concrete, the water cement ratio, that is the ratio of water to cement, the coarse and fine aggregates ratio, as we just discussed, the age of the concrete, the compaction of concrete, the temperature and relative humidity and curing of concrete. We will discuss in detail about right now curing of concrete. The curing of concrete is a method by which the concrete is protected against loss of moisture required for hydration and kept within the recommended range, because the formation of concrete is an exothermic reaction. So, a continuous water or moisture is needed for complete hydration. The curing will increase the strength and decrease the permeability of hardened concrete. Testing of hardened concrete. The compressive strength of concrete is considered the basic character of concrete. Consequently, it is known as the characteristic compressive strength of concrete, also designated as FCK, which is defined as that value below which not more than 5% of test results are expected to fall. This is based on the definition given in IS 456-2000. In this definition, the test results are based on a cube made by 150 mm size and cured in water temperature of 27 plus minus 2 degrees centigrade for 28 days and tested in the most saturated condition under direct compression. Other strength like direct tensile stress, flexural stress, shear stress and bond stress also are directly proportional to the compressive stress. Higher the compressive stress, higher are the other stresses also. Not only stresses, other properties, for example, modulus of elasticity, abrasion, impact resistance, durability are also taken to be related to compressive strength. Hence, compressive strength is an index of overall quality of concrete. The factors affecting compressive strength. As we just discussed that compressive strength is the main strength based on which we can decide about the quality of the concrete. So, among the materials and maximum mix variables, the water cement ratio is the most important parameter governing the compressive strength. Besides water cement ratio, there are few more factors that affect the concrete strength, that like characteristics of the cement, the characteristics and properties of aggregates, degree of compaction, the efficiency of curing, the age at the time of testing and the conditions of testing. Let us discuss about tensile strength. Tensile strength of concrete under direct tension is very small and generally neglected in normal design practice. Although the value ranges from 10 to 15% of its compressive strength. An average value of 10% is the proper choice. The direct tension method suffers the problem like holding the specimen properly in the testing machine and the application of uniaxial tensile load not being free of any eccentricity. The tensile strength can be calculated indirectly by loading a concrete cylinder to the compressive force along the two opposite ends with its axials horizontal. Due to uniform tensile stress acting horizontally along the length of cylinder, the cylinder splits into two halves. The indirect tensile stress is known as splitting tensile strength. Flexural strength. Maximum tensile stress resisted by the plain concrete in flexure, that is bending, is called flexural strength or modulus of rupture. It is expressed in Newton per mm square or kg per meter square. The most common plain concrete subjected to flexure is in a highway or runway pavement. The strength of pavement concrete is evaluated by means of bending on a beam specimen. The flexural strength, also called as modulus of rupture, is determined by testing standard test specimens of 150 by 150 by 700 mm over a span of 600 mm or 100 by 100 by 500 mm size over a span of 400 mm under symmetrical 2-point loadings. The shear strength. Shear strength is the capacity of concrete to resist the sliding of the section over adjacent section. A good amount of shear strength capacity is possessed by concrete depending upon the grade of concrete and the percentage of tensile reinforcement in the section. It is very difficult to obtain shear strength of concrete by IS codes suggest the value for different grades of concrete. Methods of proportioning the concrete mixes. If we want to design a concrete for a specific purpose, the concrete mix has to be designed. The proportioning are the methods which are based on certain fundamental concepts. For example, the different proportioning methods include number 1, arbitrary method. This method is adopted only for work of a small magnitude or of moderate importance. Second is minimum voids method. In this method, the voids of the coarse aggregate and fine aggregate are determined separately, and the quantity of sand used should be such that it completely fills the voids of the coarse aggregate. Similarly, the quantity of cement used should be such that it fills the voids of the sand. So, a dense mix having minimum voids is obtained. Other method of proportion is the maximum density method. The method of minimum voids later was improved by Fuller to get a grading of materials to get maximum density. There are other methods which are used for the proper designing, and to mention it, I would like to share the IS code method. The mix designs are made by IS 10262 2019 for the purpose of mixes. The grades of concrete. The Indian standard IS 456-2000 specifies 7 grades of concrete which are designated as M, M10, M15, M20, M25, M30, M35 and M40. In the designation of the concrete mix, the letter M, as I told, it refers to mix, and the number that I just spoke, it is nothing but specified characteristic compressive strength, that is the FCK of 15 centimeter cube in 28 days, which is expressed as Newton per mm square. So, M designates the mix and the number designates the characteristic compressive strength after 28 days. The characteristic strength already discussed is the strength of material below which not more than 5% of the test results are expected to fall. These are some gradings of classification. The concrete is divided into majorly three groups: ordinary concrete, standard concrete and high strength concrete. M10 to M20 is taken as the ordinary concrete, M25 to M55 is taken as the standard concrete, and high strength concrete ranges from M60 to M80. The non-destructive testing. There are, as the name suggests, non-destructive, that is, we don't destruct the sample and we want to know about the strength. So, there are methods which are used. The methods are: non-destructive test is a method of testing existing concrete structure to assess the strength and durability of it. Nowadays, this method has become a part of quality control process. This method of testing also helps us to investigate the crack depth, micro cracks and the deterioration of the concrete. Non-destructive testing of concrete is a very simple method of testing, but it requires skilled and experienced persons having some special knowledge to interpret and analyze the readings that are being obtained from the test. The different methods of non-destructive testing are: number one, surface hardness test; second, rebound hammer test, this is most common method; third one, the penetration and pull out technique; dynamic or vibration test; combined method, the radioactive and nuclear method; magnetic and electrical methods; and acoustic emission techniques. Now, we will discuss about some properties like the elasticity, creep and shrinkage. The modulus of elasticity of concrete is defined as the slope of the line drawn from a stress of 0 to a compressive stress of 0.45 FCK. As concrete is a heterogeneous material, the strength of concrete is dependent on the relative proportion and modulus of elasticity of the aggregates. Dynamic modulus is the ratio of stress to strain under vibratory conditions, calculated from data obtained from either free or forced vibration test in shear, compression or elongation. It is a property of viscoelastic materials. Now, the creep in concrete is defined as the deformation of a structure under sustained loading. Basically, long-term pressure or stress on concrete can make to change its shape. This deformation usually occurs in the direction the force is being applied, like a concrete column getting more compressed because of the continuous loading or sustained loading, or a beam which is bending because of the sustained loading. The creep does not necessarily cause concrete to fail or break apart, but when a load is applied to concrete, it experiences an instantaneous elastic strain which develops into creep strain if the load is sustained. Creep is factored when concrete structures are designed. Factors affecting creep. Number 1, aggregate. The aggregates undergo very little creep. It is actually the paste which is responsible for the creep. So, the cement paste plays a role in creep. However, the aggregate influences the creep of the concrete through a restraining effect on the magnitude of the creep. The paste which is creeping under load is restrained by the aggregates which does not allow it to creep. The stronger the aggregate, the more is the restraining effect, and therefore, the result of magnitude of creep will be less. The modulus of velocity of aggregate is one of the very important factors influencing creep. It can be easily imagined that the higher the modulus of velocity, the less will be the creep. Lightweight aggregates show substantially higher creep than the normal weight aggregate. Obviously, because of the lightweight, they are having less resistance against the loading. Next point is the mixed proportions. The amount of paste content and its quality is one of the most important factors influencing creep. So, a poor paste structure undergoes high creep. By poor paste, we mean more amount of water or less amount of cement, so that is going to create a poorer paste. Therefore, it can be said that the creep increases with the increase in water cement ratio. In other words, it can also be said that creep is inversely proportional to the strength of the concrete. That is, more the strength, less will be the creep. Broadly speaking, all other factors which are affecting water cement ratio are also affecting the creep. Next factor is the age of concrete. The age at which a concrete member is loaded will have a predominant effect on the magnitude of creep. This can be very easily understood from the fact that the quality of gel improves with time. So, such gel creeps less, whereas a young gel under load being not so stronger creeps more. Unlike brittle fracture, the creep formation does not occur suddenly upon the application of the stress. Instead, strain accumulates because of the long term stress. Therefore, creep is a time dependent deformation. It works on the principle of Hooke's law, that is, the stress is directly proportional to strain. Next property is the shrinkage. The volumetric changes of concrete structure due to loss of moisture by evaporation is known as concrete shrinkage or shrinkage of concrete. So, because of the loss in moisture, the concrete will be changing its volume and the volume will become less. So, it is called as the volumetric change or shrinkage. This also is time dependent deformation. This will reduce the volume of concrete without the impact of external forces. The types of shrinkage in concrete. Now, in order to understand this aspect more closely, the shrinkage is again classified in 4 ways. Number 1, plastic shrinkage in concrete, the drying shrinkage in concrete, autogenous shrinkage and carbonation shrinkage in concrete. The durability. The durability of concrete is its ability to withstand environmental and structural challenges over time while maintaining its engineering properties. This includes resisting the weathering, chemical attack, seawater attack, abrasion, etc. Now, different concretes require different degrees of durability depending upon the exposure and environment and the properties desired. For example, the concrete which is exposed to tidal seawater will have different requirements than an indoor concrete. The factors affecting durability of concrete. Durability of concrete depends on the following factors, and the most important or number one is sulfate attack. The sulfate attack denotes an increase in the volume of cement paste in concrete or mortar due to chemical action between the products of hydration of cement and the solution containing sulfate and sodium, magnesium and chlorides. In hardened concrete, the calcium aluminate hydrate, that is called as the CaH, can react with sulfate salt from outside. The product of reaction is calcium sulfoaluminate, which can cause an increase in volume up to 227%. The rate at which the sulfate attack increases is with saturated sulfate solution. A saturated solution of magnesium sulfate can cause serious damage to concrete with high water cement ratio. Number 2 is chloride attack. The chlorides in the concrete increases the risk of corrosion of steel, which is nothing but a electrochemical reaction. Higher chloride content or exposure to warm, moist conditions increases the risk of corrosion. To minimize the chances of corrosion, the levels of chlorides in concrete should be limited. The total amount of chloride content as Cl in concrete at the time of placing is provided by common specifications and standards. Efflorescence. Efflorescence in concrete is a whitish colored powder deposition of salts on concrete surface that is formed due to evaporation of water from the concrete. It is caused when the water soluble salts are present in the concrete material, which comes to the surface while evaporation of water from the concrete. Now, to summarize, the water cement ratio significantly influences the properties like the strength, the durability and workability effect of concrete. So, this is one factor which is going to influence all these properties of concrete. The concrete strength, crucial for structural integrity, is primarily assessed through its compressive strength, which indirectly gives the other properties like the tensile and the flexile strength. Tensile strength, although only 10 to 15% of compressive strength, is critical for concrete's ability to withstand bending and cracking. Factors such as the quality of raw materials, curing conditions and mix proportions affect the strength of concrete. Proper curing improves the strength and reduces the permeability, while the different testing methods including non-destructive techniques ensures quality and durability. The shrinkage and creep, time dependent deformations must be considered in the design to prevent the long term structural issues. Durability is also influenced by environmental factors like sulfate and chloride attacks, which can deteriorate the concrete with time. So, this brings the end to today's lecture. I trust you have gained a valuable insight about the concrete both in the green state and hardened state. Thank you.